let's do the unit time trajectory. So in this case, unit time means you're starting from t0 is 0 seconds, and you stop at tf equal to 1 second. Okay? Q of t0 is q naught. Same thing, v of t0 is v naught. These can be anything. So you can come up with any values that you want to. Here we'll say QF, and we'll say this is VF. All right. Now what I'll do is I'll add one more condition here. I'll say starting and stopping at rest. Okay. When you see at rest, that means this is 0 and VF is 0. Okay. You start from rest and you stop at rest. All right. Let me make sure that I have a set of initial conditions we have. Yeah, we're starting from rest. So the only thing is we move from Q0 to QF. Okay, so the motion, joint motion is from Q0 to QF, and you're stopping at both places like this. All right, so let's set up the polynomial so we can have that worked out. Okay, so at t equal to t0, q of 0 will be equal to so we know A naught is equals to Q naught. Then we have, let's do V naught. That will be 0 and so same thing as previously, these two will be the same. At t equal to tf, we have q of tf will be equal to a naught, a1 tf, a2 tf square plus a3 tf cube is equals to. All right. Here tf is 1. Right, this is TF is equals to 1 second. So this will be equal to A naught, A1, A2, A3 will be equal to QF. This is 0 from here. A1 is 0. So A2 plus A3 will be equal to QF minus Q naught, because this is Q naught. From here, this is Q naught. All right, let's call this as equation 1. Let's do same thing, V of TF. V of TF will be this, which is A1 to A2 TF plus 3a3 tf square will be equal to 0, because your final velocity is 0. So here a1 is 0. You will have a2 plus 3a3 is equals to 0. All right. So here you can say from these two, we can say that let's get, all right, what I'm going to do is I'll multiply 1 times 2. So that will be equal to and then we have here right. So if I subtract this, I'll have so A3 will be equal to minus 2. So A2 will be equal to so we can write Q of t, which was equal to A naught, A1t, A naught is Q naught, A1 is 0, plus A2. A2 is this. Alright, so this will be Q. In terms of the initial and final position. Same thing with V. V of t will be equal to A1 right? So this will be equal to A naught. A1 is 0, 2A2, 2 times A2, so this will be 6. QF minus Q naught T plus 3 times, so minus 6 okay. This is, so if you want to, when you try to do a plan the motion, you can just set up this equation and automatically the coefficients are calculated by this. Because you have A1, A2 already defined in terms of your final position. Same thing you can do, differentiate this one more time and you'll get your acceleration. If you want to plot the acceleration, A of t will be equal to so this is a very simple case. Obviously, you're not tracking the acceleration. This is not being tracked. This, using a cubic polynomial, you cannot track the acceleration. Okay. You're unable to track the acceleration using a cubic polynomial. Now, let me, before we go on to a system where we can track the acceleration also, let's say that I'm moving from, I have a point A, I'm having a point B, and I have another point C. Okay, so let me do it like this. This is point B. I want to move from point A to point B, but in between, I want to stop at some point C. Okay, so if I give you an example like this, and I say I start from rest here and I stop at rest, all right? But at C, I want to maintain a velocity of 1 degree per second. How do I do this? So usually if this was not there, if point C was not there, I'm starting from rest and stopping at rest. You can use this, one of these polynomials and you can do it. But if I'm stopping in between, this is a via point. So this is a So I want to go through this point, and at this point I want to maintain a velocity of 1 degree per second. How do I do this? Let's say here my Q naught, here my joint displacement Q is 10 degrees. I want here Q to be, let's say, minus 50. Here my Q is minus 30. Okay. So in this case, what you'll have to do is do two polynomials. That is, one cubic polynomial will take you to C, and the second polynomial will take you to B. From C, you'll go to B. Okay? So you'll generate one trajectory here. This will be the initial condition. This will become the final condition. For this leg of the journey, this will become the initial condition, and that will be the final condition. Okay? So you'll divide this between, depending upon how many via points you have, if they are well defined, you can split the trajectory into this will be cubic 1, and this will be cubic 2. Okay, so you'll divide this into two trajectories. This will be one motion, this will be one motion, but it will be continuous, because now here at t equal to, let's say the whole motion is defined over a timeline. This is t is equals to 0, and this is t is equals to, let's say, 5 seconds. At t equal to 3 seconds, I want to be at C with this velocity, and this is my joint displacement. So you'll plan this cubic trajectory as one trajectory, this will be a second trajectory, and then you club the two, so you have motion, continuous motion like that.
So at cubic 2 will not be 0.
At C will not be 0. Okay, it will be non-zero. It will be Vf, some value Vf. And then when you start from here, V0 will become non-zero. Because now this is the initial condition for this part. Here, for this trajectory, A is the initial, C is the final condition, right? For this part of the journey, C is the initial condition, B is the final. Got it? So, initial condition here will be Q of A, right? Whatever at A conditions are. Here, it will be Q of C. This will be initial, final. In this case, Q of C will be initial, Q of B will be the final. Okay? All right, let's do one small topic, which is, let's say I want to track the, now you know the limitations of this method, which is you can very well track the position, you can track the velocity, but you cannot track the acceleration. What is the order of the polynomial I need to track the acceleration also? 3 is already here, man. Cubic is degree 3.
Oh, for the A, it needs 1.
If I want to track A also, now right now I'm tracking Q, I'm tracking V, I want to track A also. So this is done using a cubic, right? This is a third degree polynomial, will take you, cover these two. If I want to cover acceleration also, what should be the degree? 4 will give you, so let's say we have a fourth order, right? So Q of t you have 5 coefficients, right? Previously you had 4 coefficients, you have 5. This has 2 conditions, right? Initial and final. This has 2 conditions, initial and final. And this will also have 2 conditions, initial acceleration, final acceleration. With 5, I cannot cover 6 coefficients, 6 states, right? I need one more coefficient so that I can have 6 states and I have 6 coefficients. So it has to be a fifth, if you want to track the acceleration also, it has to be a 5th order polynomial. So this is called a quintic trajectory. Okay, this is a 5th order polynomial, so now you can track velocity as well as acceleration. of A. Here we will have so obviously we are not going to solve it like this. It becomes impossible to go on solving like that. So we resort to doing this in the matrix form like we did previously. So this will be A0, A1, A2, A3, A4, A5. Here you'll have initial position, initial velocity, initial acceleration, final position, final velocity, final acceleration. Okay, so here you have 1 at t equal to t0. This is initial condition, so this will be t0, t0 squared, t0 cube, t to the power of 4, and t to the power of 5. Okay, then this will be 0, 1, 2 t0, 3 t0 squared, 4 t0 cube, and 5 t0 to the power of 4, which is this. Substitute t equal to t0 in this set of equations for initial condition. So here you'll have 0, 0, 2, then you'll have 6 t0, 12 t0 squared, and 20 t0 cube. Okay, these are the first three set of equations. This is t is equals to t0. Here we'll have t is equals to tf, because that will lead you to the 3, 5 conditions. So here we'll write this as 1 tf, tf squared, okay, and finally we'll duplicate this row. Only thing is you'll have this as tf. 20 tf. So this you can solve. This is your T matrix. This is A, and this is constant. So A will be equal to. All right.
Guys, the robotics club will meet today in the library from 6 to 7 in room 5 in the first floor. So if you're interested, we're going to be setting the date for the weekly meetings and start working on projects. So today, room 5, 6 to 7.